Sidney.
Hello, Linda.
Hello, everyone, and welcome back to Linda's Corner on SolidCAM's Insights. Today's episode is a special one for anyone in the world of CNC machining, CAM, and manufacturing innovation. Today, I'm joined by Sidney, Senior Vice President of Product at SolidCAM. Sidney's journey is anything but typical, starting out as a CNC machinist, writing G-code by hand, spending 17 years on the shop floor, and then transitioning into product leadership, where he's helped shape some of SolidCAM's most widely used features. From developing core functionalities that have stood the test of time to teaching users around the world, and now helping drive the integration of AI-powered tools like CAM Assist, Sidney brings a unique perspective that bridges real-world machining and advanced software development. So let's get into it.
Okay, go ahead.
Okay. So Sidney, today you are Senior Vice President of Product at SolidCAM, responsible for the development of many SolidCAM functions. You started originally as a CNC machinist, like I've said before, writing G-code by hand, and worked 17 years on the job floor. What did that experience teach you to enable you to do your tasks at SolidCAM the best?
Well, definitely yes. Working on the shop floor teaches you things you simply can't learn behind the desk. You get a feel for the machine, how it behaves, how setups work, how different materials respond, and what actually happens when the tool hits the part. So that physical understanding is critical. Without it, you're just working in theory. Now, as product managers, we define to our software developers what we want them to do. But the best programmers go a step further. What do? They ask why. They challenge decisions, and in many cases, they'll even come down to the shop floor and see the processes firsthand. Now, at SolidCAM, we have a lot of programmers just like that. They don't just sit behind the desk, they engage, they observe, and they learn from real machining conditions. Will they ever have the exact same intuition as someone who spent years of running machines? Probably not. But that collaboration between real shop experience and strong software development is what leads to the best results.
I guess that's why SolidCAM is so successful.
That's it. Has a lot to do with it.
So you started teaching just a month after joining SolidCAM.
That's
and
correct.
For many years, you were known as the SolidCAM professor with the hat. How did teaching users shape the way you think about product design?
That's actually a very, very good question. The answer is simple. Teaching users had a huge impact on how I think about the product design. When you're training customers, you're not just explaining the software, but you're experiencing it through their eyes. You see where they struggle. You see things that aren't intuitive and where the workflow could be simpler. That naturally makes you think, why does this take so many steps? Okay, can we make it easier? So teaching really pushes you toward designing more intuitive and efficient workflows. As for the SolidCAM professor title, well, that's a little story. It actually came later. After a show that was in the US together with Emil, we saw something called Solid Professor. And we thought, we can do something similar and better for SolidCAM. So we created SolidCAM Professor, and I started recording training content based on what I was already teaching. So in a way, the title came from the teaching, but the real value was how teaching continuously gave me feedback into improving the product.
Listen, you're a good teacher. I mean, not everybody can teach, but I have seen you train. I've seen you teach. You're good at it, Sid.
Thank you. Actually, Linda, I was never taught. until I started working in SolidCAM.
Wow. Okay. So you've worked on features that are still core today, like T-slot operations from 2007. What makes a CAM feature timeless?
Well, timeless, that's a good question. What makes a CAM feature timeless is that it solves a real reoccurring problem on the shop floor and does it in a way that's simple, it's reliable, and it's efficient. Now, if a feature is still being used years later, it means it wasn't built on some trend. It was built around how machining actually works. Those needs don't change over time. Now, features like T-slot operations last because machinists trust them. They know what to expect, they know it works, and it consistently delivers good results without unnecessary complexity. So for me, a timeless feature is one that stays relevant, not because it's new, but because it continues to make the job easier every single day.
Okay. Tell me, and what about drag and drop? I mean, the drag and drop template sounds simple, but it's widely used. What problem were you trying to solve there?
Oh, okay. Well, what it was really solving, well, I should say, what I was really solving there was the inefficiency of repeatedly defining the same operations over and over again. Users were performing identical setups again and again and again, which was time consuming. And you're prone to do some errors over there when you're doing it over and over again. So drag and drop templates eliminated by just letting users predefine operations once, save it as a template, and then simply drag it onto a SolidCAM geometry. So instead of going through the full step each and every time, the operation is instantly applied. So it significantly reduced repetitive work,
For
improved
sure.
consistency,
For sure.
and made the workflow much faster and more intuitive.
Wow, that must have been so popular.
It was real popular when it first came out. People loved it
Wow, okay.
and still use it today.
So another timeless feature.
Exactly.
Are some functions driven by customers' pain points, like say multi-depth drill?
Well, that's actually a very good question. And the answer is yes. This is very much driven by real customer pain points. Particularly, you mentioned multi-depth drill. So in that particular case, like customers were performing multi-step drilling operations, uh, and they needed precise control at different depths, but they were defining each step manually, and this was time-consuming and inefficient. So we introduced multi-depth drill to give them that control in a structured way. But it didn't stop there. Customers then told us, you give a person a hand, they want the whole arm. So then they told us manually defining every level was still too much work. So we took it a step further and added a bit of automation. By recognizing where material actually exists, the system can automatically generate those depth levels for them. That significantly reduced setup time while still giving them full control if needed. Because of that balance between control and automation, the feature was widely adapted. And not only was it widely adapted in milling, now we have it in turning as well.
Really?
Yes.
I didn't know that.
That's right.
Wow.
Learn something new every day.
Wow, that's really interesting. Everybody's asking me, I do the orders. Everybody asks me to open the multi-depth drill. It's a real winner, this one. So let's change gears. You've been closely involved in defining Cloud NC CAM Assist integration in SolidCAM. How do you see its role in CAM programming? And is it meant to think like an experienced machinist or act as an intelligent assistant?
Well, I see canvases primarily as an intelligent assistant, not a replacement for experienced machinists. There's a level of judgment and experience that machinists bring which cannot be replaced. What canvases does is it leverages the information you provide, your setup, your tools, and use that to suggest machining strategies and operations. It helps guide decisions makings and significantly speeds up programming processes. But machinists remain in control. You can accept the suggestions, you can refine them, or you can take a different approach. It's all up to you. So its role is really to enhance the machinist, helping them go to a solid result much faster while still relying on the experience for that final decision.
Okay. So do tools, so how does CAM Assist support machinists in decision making? And where should users rely on CAM Assist versus their own experience?
Well, CAM Assist supports machinists by turning all the inputs they already defined, as I mentioned before, the model, the setup, the tools, the material, into intelligent machining suggestions. Instead of starting from scratch, it gives them a strong, data-driven starting point for operations and strategies. Where it really helps is in speeding up decision-making and reducing the trial and error phase. That said, it's not a replacement for experience. Machinists should rely on CAM Assist for guidance and efficiency, but always validate the results. If the suggested strategy aligns with their knowledge and the goals as well, then use it directly. If not, they can refine it or override it, write a new line of another operation instead. So the balance is use CAM Assist to get there faster, but rely on your experience to make the final call.
Okay. So that's what I was thinking, because machinists like to be in control. So do tools like CAM Assist help reduce the skill gap in CNC manufacturing? And how do you build the trust with the machinists who are used to being in full control?
Well, yes, tools like CAM Assist can absolutely help reduce skill gap in CNC manufacturing. Now, they lower the barrier to entry by giving less experienced users a strong starting point. Instead of relying entirely on years of experience, they can leverage guided suggestions based on best practices, where at the same time, more experienced machinists can use it to work faster and more efficiently. As for trust, it builds through transparency and control. Machinists can see exactly what CAM Assist is doing because it's based on the inputs they provided, that the machinist provided, the setup, the tools, materials. Nothing is hidden.
Okay.
And most importantly, they're always in control. They can review, adjust, and completely override any suggestion that's given. Over time, as you see a consistent and reliable results, the confidence, like in any other system, naturally grows.
Absolutely.
So it's not about taking control away. It's about supporting the machinists while keeping them firmly in charge.
Okay. So let's talk about something else now. How do you decide which features to develop next? Like the automation provided by whole segment features coming in SolidCAM 2026. That's a sneak peek, by the way.
Well, Linda, that's a phenomenal question. That really is a good question. Now, because it's not one particular thing, there are a few key drivers behind how we decide what to develop next. And the first, and I think also foremost, is customer demand. When we consistently hear users asking for capabilities, especially if they've seen it somewhere else, that's a strong signal. But we don't just replicate those features, what they see. We aim to deliver them in a more intuitive and a more efficient way. Second is hands-on insight. By working closely with the software, which I do every day, I can identify friction points or areas where workflows can be simplified. Those observations often lead to meaningful improvements. And third is leveraging innovations across the product. When a new capability is added to one area of the product, we look at how we can apply this elsewhere to create more values and consistency in SolidCAM. So it's really a combination of customer feedback, real world usage, and internal innovations that drives what we build next.
Wow, interesting. Okay,
It was
so
a loaded question.
so let me ask you a personal question. You have a passion for photography, and
Yes.
you're really good at it. You even won several awards over the years. Does photography give you something that engineering doesn't?
Boy, I'm really glad you asked that question because I really do like photography.
I know.
Well, photography is definitely my passion. And interesting, it's that it shares a lot with engineering in certain ways. There are rules. Just like engineering has rules, photography has rules like lighting, timing, composition, and also understanding your subject. But where it differs is the freedom of spontaneity. Engineering is more structured for methodical, while photography allows you to capture something unique in a single moment, something that may never happen the same. It may not happen again. That ability to recognize a moment, frame it, and preserve it, that's what makes photography. That's what photography gives me that engineering doesn't.
Well, your room is filled with your pictures. I mean, gorgeous pictures, I might add. Gorgeous,
Thank you,
gorgeous
thank you.
pictures. Okay, so Sidney, after everything you've built, what are you most proud of? What is something you're proud of that people might not realize?
I would probably say one thing I especially proud of, and people don't even realize its impact, is smart face feature in SolidCAM. Now, on the surface, it looks like a simple, like simple capabilities, clicking on a face to automatically create geometry. But that simplicity is exactly what makes it powerful. Now, it actually became the foundation for other workflows. Like we mentioned before, drag and drop is based on the smart face, drag and drop templates, and even how surfaces are quickly defined in iMachining today. Now, what makes it meaningful to me is how it started. From a simple question, you gave webinars many times. So during a webinar, I was showing them how to create geometries, and they asked, can this be made easier? That pushed me to rethink the entire approach. So I worked closely with development to turn that idea into something intuitive and seamless. So while it may look like a small feature, it ended up enabling a whole range of capabilities, and that's something I'm really proud of.
Wow, 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 Sidney. Okay. Thank you, Sidney. That was an insightful look at how deep machining experience, teaching, and product thinking all come together to shape the tools that so many rely on every day. So from timeless features to the role of AI in CAM programming, it's clear that the future of manufacturing is being built on both experience and innovation. So again, thank you, Sidney, for sharing your story and your perspective perspective. And thanks to our listeners. See you next time.
Thank you very much for having me.
Thank you. Bye-bye.
Bye-bye.